Hello everyone, I am Dr. Rajesh and I am again with you with my next video lecture. And as promised in the earlier video lecture, I have come up with the new topic, and that new topic is all about the relation between the delta you have studied is forward difference operator, that is del operator, that is backward difference operator. E is the shift operator, and delta, this small delta, this is capital delta and this one is small delta, stands for the central difference operator, and this mu stands for the average operator. So that is average operator. This is the differential operator. Differential operator simply means d by dx, differentiation with respect to the independent variable. So in the earlier lecture we have already studied their definitions in detail, and we now are concentrated more about the relation, what will be the relation between them. So that is much more important. And in the last lecture I have already told you that there is hardly any chance in the examination that this type of question does not appear. So you better it will be if you prepare these kind of questions. Question is very simple, to establish the relation between these operators. So now moving further, we will see the first relation is that E is equal to 1 plus delta. Once again I will elaborate this. E stands for shift operator, and this delta is the forward difference operator, and this one stands for the identity operator. Here one is of the same type operator. If this is forward difference operator, this one is the identity operator. So this E is equal to 1 plus delta. Now we will see what is the, we know that if we start from this side, 1 plus delta, when this is the operator, and when operated upon the operand, and we have taken the operand as fx, so what will it will give? It will give, this will go inside and this will go inside, so we'll get fx plus delta fx. Now further, using the definition of forward difference operator, here we know the forward means in the forward direction, so this will give fx plus h minus f of x. Once again it is mentioning here that we have used this definition of the forward difference operator. Now you can see that this and this is cancelling out, so we are left with f of x plus h. So by definition of shift operator, we know that when E is operated upon fx, it will give back f of x plus h. This is the relation. So comparing both these two sides, we get, so 1 here is meaningless because 1 is obvious, so this implies that 1 plus delta is equal to E, because this relation is holding good for all fx. For all such fx, this relation is holding good. So therefore we have successfully established the relation. The relation is 1 plus delta is equal to E. So this relation is very important, you could mark it as important for the examination. So and the relation will be frequently used in proving many identities in the following course. So you must take care of this expression and try to understand it, and you have to keep it in memory also, because this relation will be used very frequently. So now next we will move, if in the examination you are asked to prove that this is del backward difference operator is equal to delta. So how will you prove? So proof is very simple. We are starting with the left hand side. So this is simply operator, both these two are operator, and these are when operated upon the operand, and operand here is f of x. So it will get, you will get E del fx. So now we'll use the definition of the backward difference operator, and you better know it will be fx minus f of x minus h. So the definition has been used here, and it is also mentioned along with it that why we have written something like that, because it is by definition of the backward difference operator, which simply states that it is equal to fx minus h. So now this shift operator is distributive over addition, so this will go over here, this will go over here. So at the both places we have written E and E. Now again using the definition of shift, it will shift it in the forward, so it will become f of x plus h. It will shift in the forward x minus h plus h, so this will be f of x. So simply the definition is used, and this is the definition. So this is the definition, and here you see this is nothing but delta of f of x. This is delta of f of x, and once again it is written that this is equal to this one. This is the definition of forward difference operator. This is delta. Okay, so this thing is equal to this and holding for all fx. So hence this is equal to this one, and this is an what we'll call identity. So this E del is equal to delta. So this is important from the examination point of view. Next we will move towards the other identity. So you must grasp the idea of both the identity that we have taken so far. So this is the next identity. So we will start with the left hand side. So this is this one, this is delta, this is del. So firstly it will operated by fx will be operated by del. So when it is operated, use the definition is used. This is the definition. So now this will distribute over the addition. This plus could be written as plus minus, so this is distributed over the addition, and one more, del of c fx is equal to c del delta fx. So that property is used. So this is delta fx minus delta fx minus h. So that distributive property is used. So now again we are using the definition. Here we have used the definition of the forward difference operator. This is the definition. So this will be, and in the backward sense if we write, this is in the sense of forward, and in the if we write it in the backward, so what it will be? It will be del fx. Okay, because del fx is equal to fx minus f of x minus h. So this will be the this fx can be taken outside, so both operand it will hold for all the operand fx, all such operand fx. So this is holding for all such operand fx. So as an identity both will be equal. So in the next step we will put them as equal, so that we have established that both these, that is delta del is equal to delta minus del. So we have established the third identity, and this identity is important from the examination point of view, and this is the third identity establishing the relationship, different relationship between the 6 terminologies that we have studied in the last lecture. So that is the third identity. Now we will be moving towards the fourth identity, and you can mark it as an important one. Prove that E is equal to exponential hd, where d is the differential operator. Fine. So now we will start proving it. E f of x is equal to f of x plus h. You know by the definition of a shift operator, this thing you know. Now next what we'll do, you will use the definition of Taylor's theorem, where h is very small as compared to x. So this will be f of x plus h f dash x, where this prime stands for differentiation with respect to x, plus h square by 2 factorial f double dash x. Fine, and so on. So next we are going to use, in place of this dy dx, because this is the definition of differential operator, dy dx is equal to capital D. So we have used this one over here. So next it can be written as this one, fx can be taken outside, this is h square, this is d square, and so on. So by definition of exponential e raised to the power x, we get e raised to the power hd, this is equal to e raised to the power hd, because by definition of exponential e raised to the power x, we get e raised to the power x is equal to 1 plus x square by 2 factorial, and so on. So we have used this definition, this expansion in this term. So we will get e raised to the power hd fx, and this is holding for all such fx. So this will be e is equal to e raised to the power hd. So this establishes the fourth identity, and this identity establishes the relation between this shift operator and the differential operator. So from your book you could also study other relationship between these 6 operators, and the line of action I have discussed with you through these 4 identities. So these identities were very simple yet very important from the examination point of view, and I hope you all will be able to understand and grasp the idea of these 4 identities. So that is making use of the definitions that we have studied in the last lecture. So that was all about the relationship between these 6 terms. Now next we will understand the definition of interpolation. Okay, so we'll just try to understand what interpolation means. So in the last lecture I had also tried to explain the meaning of interpolation. Now we will study that concept, that what is the meaning of interpolation. So introduction to interpolation. Interpolation is the process of computing intermediate value of a function y is equal to fx from a given set of tabular values of the function. Say the value of function y is equal to fx. So is given at point x naught, x1, x2, which is y naught, y1, y2. These values are given. So we have to find some intermediate value. Intermediate means, if I say this the value in between any of them, between x naught, x1, x2, or between any number, we find the at any point we find the value of function at that point, then that is process is called interpolation. Like here we are taking it through an example. The population of the town is given below. Estimate the population for the year 1895 and 1930 using suitable interpolation. Now why it is interpolation? Like in 1891 population is in thousand 46,000. In 1901 it is 66,000. 1911 81,000. 1921 93. 1931 101. So now we are asked to find the population in the year 1895. So that year is falling here. So that year. So and this year 1930, this is falling in between these two. So this is the interpolation from the beginning of the data, and this is interpolation from the end of the data. Likewise, it is in between the values, not outside. If we are required to find the value outside of it, then it will be called extrapolation. Instead of interpolation, it will be extrapolation. So we are not interested in that. So this is all about the definition of interpolation. In interpolation, the value is in between them. So this value is in between the given points. So now next we will move towards what are different interpolating curves. So we interpolate the data through linear polynomial connecting two data points like this and this point. So these 2 points are connected through each other through a linear polynomial, and this is true for a 2-point data. This is true for 2-point data. So this is a linear polynomial, like we are given 2 points data, and this interpolation is called linear interpolation. So in the examination it could be asked that what is linear interpolation. So you will simply say that it is 2-point data in which those 2 points are connected linearly. If the 3 points data, the 3 points could be connected through a non-linear curve, and that non-linear curve will be a quadratic polynomial. So we can fit a quadratic polynomial to the 3-point data. So that the questions we will also study based upon that, where we will be given the set of points, or we can say that say n set of points. So in that, which type of polynomial could fit into and what is its degree, that we will study at the later stage. So now this is the quadratic polynomial that could fit into 3-point data, like here this point, and this point. Say this point is, if I say point number 1, and this is point number 2, and this is point number 3. So these 3 points are connected through a quadratic polynomial, and this type of interpolation is called quadratic interpolation. So that is quadratic interpolation. So now we will see what is cubic. 4-point data if we are given, so like here 4 points 1 2 3 4. So this 4-point data is given. Say this is point number 1, this is point number 2, this is point number 3, and this is point number 4. So this 4-point data is given, and in this 4-point data, which type of polynomial could fit into cubic polynomial? Cubic polynomial could fit into these 4 data points. So that type of interpolation is called a cubic interpolation. So that is the third type of the interpolation, in which the 4 data points are given, and the 4 data points are given, then that type of interpolation could be approximated with the help of cubic polynomial, or this type of interpolation is also called cubic interpolation. Like here, this is the cubic interpolation. Okay, fine. So this is cubic interpolation. Now next we will move towards, so these 3 types of interpolation we have studied. Once again I am revising. Firstly, interpolation to find the value at the intermediate point. Intermediate means in between the given points, to find the value of the function at the intermediate points, and I have illustrated it through the well illustrative example, this one, where 1895 and 1930, at these 2 points the value of the function is to be calculated, that is the population is to be calculated in this particular case. Then we studied the type of interpolations. First was linear interpolation. When 2 data points are given, then a linear polynomial could fit into it. Then we studied the quadratic interpolation. If 3 data points are given, then a quadratic polynomial connecting these 3 points could fit into it. So that type of interpolation is called quadratic interpolation. Another one was, if the 4 points of data are given, then that is called cubic polynomial connecting 4 points data. So this is these are the 4 points 1 2 3 and 4. So if the polynomial that could fit into in these 4 points is called cubic interpolation. So in this lecture we have studied, I am summarizing the relation between the 6 terminologies, 6 terms that we have studied in the last lecture, and we have established the 4 important identities. So, and the next we studied about what is the interpolation, and we have studied it through well illustrative example and made the concept very much clear. Now after that we studied that what are the different types of interpolation that are used to approximate the interpolating curve. So 3 mainly we studied: the cubic interpolation, quadratic interpolation, and the linear interpolation. Linear interpolation when the 2 data points are given, cubic when 4 are given, and quadratic when 3 data points are given. So that is how we have bifurcated the different kind of interpolation. A different kind of interpolation in the sense that the approximating curve that we have used to interpolate the value of the function at the intermediate value. So that bifurcation is done on the basis of the approximated curve, that will approximate the function. So that was the types of interpolation. Based classification was based upon the kind of approximative curve, the curve that is approximating the given data. So that's all I have from this lecture, and in the next lecture we will study that there are two types of interpolation: interpolation for equally spaced data, interpolation for unequally spaced data, and what are the different methods to find those kind of interpolation. So till then, take care, bye bye, see you soon, and keep studying, and I will be soon with you. Thank you very much. Thank you for watching. Thanks very much.